Okay, so hello guys. So here's the next question for the problem of the day in Leetcode. Okay, that is alternating groups, and it is the second version of it. Okay, so what basically in this question is saying that we have given a circle of two colors, red and blue tiles. Okay, only two tiles. Okay, and we have given an array. Basically, in this circle we will represented in form of an array. Okay, and we have given an k. Okay, what is k we will understand later. So colors are represented in form 0 and 1. Okay, 0 means red and 1 means blue. Okay, so simply you can see. So let's just understand what k represent and what basically how this question is, what this question saying and what we have to give output. Okay, so I have made here this okay circle. So k is basically k represents the contiguous alternating groups of colors. Okay, like here if you see 0 and 1, 0 and 6, 6 5, 5 4, 4 3, they are alternating. So okay, I have taken not this example basically in which k is larger. Okay, you will understand when I will basically explain the approach. Okay, in by this. Okay, so let's just first understand the question, what is k and what is basically output of this. Okay, so we have to basically return the total number of alternating groups. Okay, so the groups, alternating groups size is k. Like here you can see that this if we take from here like from here, that is 3. So 3 4 5 6 0. Okay, that is 1 2 3 4 5 and this is 1. So total this from this has size 6, and you can see this has total alternating groups. Okay, and size is also 6. So here one basically there is a one alternating group, and here one more alternative group can be possible. Like from if you start from 4, that is 4 5 6 0 1 2. Okay, so there are two alternating groups that can be formed, that is from 3 to this and 4 to this 2. Okay, so that's why the output is 2. So this is the output that we have to return. We have to return the total number of alternating groups. Okay, of the size of k, that is k is the contiguous basically blocks or tiles. Okay, of alternating colors. So that is the basically question, and how basically we are going to deal it with. So we are going to basically use a sliding window type of approach. Okay, in which we will create a window. Okay, from which that basically that will take care of the contiguous k sized alternative groups. Okay, and we can simply count the total number of alternative groups we have seen, and we will simply return it. So if we let's just take this array. Okay, so I'm taking it. Okay, so I've taken. Okay, so this is the array. Okay, by which, and one thing is this is basically circular. So this and this last elements are also important. You can simply only one pass. Okay, so this is basically circular. So these alternating are also counted. Okay, for last and first. Okay, so that's the main approach here. Okay, so let's just see how we are going to do. So we are basically using we are going to use one I that will simply iterate through array. Okay, this I. Okay, and we will first basically form basically we will calculate all the result or all the alternating group in this array. Okay, and then we will basically start again from 0 to k minus 1. Okay, to basically ensure that there is no extra basically elements in circular order. If let's just check, you will understand. Let's just see. So this is I. At last first it will be as 0. Okay, we will take care of a one more variable, that is last color. Okay, so that will simply, if the last color is equals to the this basically current color, then we will simply restart the basically let's just take out one more variable, that will simply count of basically current alternating groups. Okay, count of current alternating groups. Okay, and one we will take result, that will simply take care of total number of alternating groups. Okay, so let's see how this is gonna work. Okay, so first I will be here. Okay, and last color would be this. Sorry, we will start from this one, because last color we will simply start with. Last color would be initially would be simply color is the array and 0. Okay, so simply first element we will store it last color. Okay, that will simply the first color. Okay, then we will start from I here. Okay, so count of current the alternating group will be simply 1. We will initialize it with 1 because first we will start from here. Okay, okay, this is not initialized. Okay, so simply it will be 1 at first. Okay, so let's just see how this is gonna work. So this is I from this here. Okay, so then I will move again. Okay, I will move on next, that is here. Okay, so it will check, and last color would be this. We will update last color every time. So last, or we can simply write last color is this. Last color would be next 1. Okay, we will simply change I to the last color every time whenever we move I. Okay, so last color would be this time this 1. Okay, so this color 1. Okay, last color would be this. I would be here. Okay, it will simply check, and the both are not equal, then we will simply append this or increase this current of current. Okay, okay, then what we'll do, we will simply move again I. Okay, I would be here, and last color would be simply 2. Okay, this, or you can basically move this also, this. Okay, this will be last color. Okay, next this time, and we will check. So this time these are equal, last color and this I is equal, so simply we will again make this 1. Okay, we will reset it to 1. Okay, then we will again move this I, this here. Okay, and last color would be simply this 3. Okay, so if you see that last color is this, let me just this. So last color is this. Okay, and this is basically current color, so they are not equal. So simply we will again just make it 2, increase it. Okay, so let's just then I will be here, and last color would be simply 4. Okay, 4th index, and we will simply see these are not equal, then simply we will append this, that is 3. Okay, then we will simply move this I would be here. Okay, and last color would be simply let's just change it, that is 5. Okay, so simply we will append it again because they are not equal, then it will simply be 4, and then we will move I, and it will simply end the basically this array. Okay, simply you will say array will be end, so I will be at last. Okay, I would end. Okay, out of bound you can say, and last color would be simply at 6. Okay, okay, and count of current basically alternating group wouldn't be increased. And now this time the main thing arises, so we will basically take care of next basically loop that will start from again 0. Okay, 0 to k minus 1. K is basically 6, that is till 5. Okay, k minus 1. Okay, next loop we will start, and these values, that is last color and count of array, they would be same, and result would also be same. We will again start from next loop. Okay, from 0, then what we will say, it will be simply at 0, and last color is 6, so they are not equal, so simply it will simply increase this. Okay, so simply it will increase to 5, and last color would be this time again 0. Okay, so simply I will also move to this, last color would be this. Okay, then simply again it will check these are not equal, then simply it will make it 6, and this time it will again let's just this time. Okay, again this will move this, and color would be this 1. Okay, and one thing I have not basically whenever this count of current AG, basically current alternating group, becomes equals to or greater than K. Okay, so this if you see this count is equals to K, then simply we will append result now, because we have got one basically this output. Okay, we have got one output, that is one alternating group, that the size of contiguous alternating group, that is size of K. Okay, then we will move this I to here and color would be here, and we will again move this count of, we will again append this count of current AG to 7. Okay, and it is now also it is greater than basically this you can say K. Okay, it is now also greater than, then we will append again the result because it is greater. So the result would be 2, and then I would become here, you can see I would become here, and color would be again this time would be simply 2. Okay, and these are basically not equal, these are basically equal, then current of this will be again be, you can say 1. Okay, this will again become 1, and then we will move I to here. Basically how many times this will move? K minus 1, that is 5, less than 5, that is till 4. Okay, and this will become 3. Okay, and the count of this will become simply 2. Okay, and this time when this will be here, the loop will exit, and you can say this will become count, this now, this doesn't matter now. Okay, so simply count will be here, you can see 2, so result will not append, result will be simply 2, and it will return 2. So this was the basically hardest input or example to understand, that's why I have taken this. Okay, so for small values, that is example, other example, it will be simply easy to understand. So so you got it, how this basically approach is working. So that's the basically we are going to use 2 loops, or you can simply use in one pass also. You can simply for first loop that we are using to 0 to this last index, you can simply add the K minus 1 more elements. Okay, so this can also be work in one pass. So the time complexity will be simply same, big of n plus K. Okay, n that is first whole array, and then K more. Okay, so simply big of n plus K, and space complexity is big of 1 because we are not using extra space. So we will see in Leetcode, and we will provide you the code in GitHub. So okay, so that's it. Okay, so here's the Leetcode, here's the basically code, or you can see first we have declare length, result, and count of alternating element in last color we have seen. Okay, so for first loop we are going to start from 1 to this array. Okay, we will calculate all the possible basically alternating element or result, you can say. If the colors are equal to the last color, okay, basically current color equals to last color, we will simply make it again to 1, and last color would be updated to color I. Okay, and we will continue, basically we will skip this iteration, and next then we will again basically append or increment the count of element alternating element. Okay, then count of, if anytime count of alternating element becomes greater than or equals to K, we will simply result plus plus. Okay, so last color would be simply equals to previous color at last. Okay, we will make this. Okay, this is important because if the last color will not be updated, we will not get the answer. Then for next K iteration, okay, for basically it is circle because that's why. Okay, for int I equals to 0, I less than K minus 1, if colors I equals to last color. Okay, if this last color, you can see here, this first color and last color are equal, then we don't have to iterate whole. Okay, we can simply break it. Okay, and simply it is break, the loop will exit, and if it is not equal, then we will simply basically increment the value of count of alternating element, and we will simply calculate result, and last will be equals to color I, and same the loop that is upward. Okay, at last we will return result. Okay, you can submit it. So yeah, you can see it's accepted code. Okay, so you can see also time complexity, that is big of n. Okay, and that is n plus k, or you can say big of n. Okay, big of 1. Okay, space complete. So that's the code.